pressure. We have to define pressure, that is normally represented by the letter capital P. It's defined as the normal force per unit surface area. Force per unit area, as far as the unit is concerned, this becomes Newton per meter square, which is normally known as Pascal, a SI unit for pressure based on the name of a scientist. His name was Pascal, and this is represented by the short form capital P small a. Its dimension is going to be mLt minus 2 upon, you would write here L2, and that becomes finally mL minus 1 T minus 2. Now, it is clear with this definition that whenever the force is applied, force is experienced by a surface, certainly there will be pressure. You see, pressure has many directions. Sometimes you come across a scalar and vector, then you are very particular for the direction. A quantity having direction is called vector. But here, pressure has many directions. Despite that, it is not vector because it doesn't follow the laws of vector. Pressure is a scalar quantity. Now, what is atmospheric pressure? You see, above the earth, that's not true with all the planets, but as far as our planet earth is concerned, around earth there is atmosphere. And suppose this is the surface of the earth, the atmosphere, that is air column above the surface, that must be having some weight, a kind of force. Force per unit area experienced by the earth, that is called atmospheric pressure. Now, why only earth? If you are standing on your head, some pressure will be experienced because of the atmosphere. That is what we call atmospheric pressure. Standard atmospheric pressure comes out to be 1.013 10 to the power 5 Pascal. Here one thing is very important. This is atmospheric pressure, one atmospheric pressure. Normally we won't say atmospheric pressure, we simply use the term 2 atmosphere. Pressure is 4 atmosphere, and that too while writing we use only 3 letters ATM. This is used for symbolizing atmosphere. And 1 atmosphere, this is equal to this much. Remember, it becomes a bit inconvenient. So, from that point of view, we have designed another unit also, that is simply 10 to the power 5 Newton per meter square, or you might say Pascal. This is known as bar. Now, this is atmospheric pressure. Suppose some person is standing on the ground, obviously he will be having his weight. Because of his weight and the atmosphere, the total pressure comes out to be 1.14 into 10 to the power 5 Pascal. While considering this important and peculiar result, we have chosen the surface area of the foot equal to 400 centimeter square. Now, you will come across one more term regarding pressure, that is gauge pressure. You see, suppose you are with a puncture shop and there you are trying to fill your tube in the tire with air from outside. That person will tell you, sir, this is 28. Simply he'll speak 28. He is not going to say 28 atmosphere. But you see, he is telling you the gauge pressure. What is gauge pressure? Greater than atmosphere. 1 atmosphere is already, everybody knows that the atmospheric pressure is 1 atmosphere. If someone says the gauge pressure is 3, it means greater than atmosphere, this is 3. Now, let me clear it more. You see, you want to find out the absolute pressure absolute. This will be atmospheric pressure plus gauge pressure. For example, suppose I tell you that gauge pressure in the tube is 3 atmosphere, then what is the total pressure there in the tube? That becomes 4 atmosphere. Once you say gauge, it means it is on the basis of atmospheric pressure. 1 atmosphere is considered there as the origin. When you consider 1 atmosphere as the origin for measurement of pressure, the reading that you will get will be known as gauge pressure. That I have clarified here. Absolute pressure is going to be gauge pressure plus atmosphere, and gauge pressure you might find out just by changing the side, another arrangement of the equation. You see, in tabular form, I have tried to represent these things. Atmospheric, I have given as a value, and this is because of the air column. Gauge pressure will be obviously the difference of absolute and atmosphere. Gauge pressure is always relative to the atmosphere, or you might say its measurement is on the basis of atmosphere as 0. Then absolute pressure, and now is the time to know the detail of hydrostatic pressure. You must know what is hydrostatic pressure. Hydrostatic pressure, static stands for rest. Hydro stands for liquid in general. So, when the liquid is in rest, the pressure because of this liquid in rest, that is known as hydrostatic. Remember, this term is not valid for gases. This is confined to liquids only. Because of the liquid, suppose its column is H, this is H, then this hydrostatic pressure is going to be H rho G. Here rho we have considered the density of the liquid. Now, in order to clarify or to know its derivation, simply let's consider this is A. Now, the volume of the liquid becomes A H, mass would be A H rho, volume into density, that's mass, weight would be mg, that is A H rho g. Divide weight by the area, you are going to get the pressure. But since this is the pressure because of the liquid only, that's why it would be called hydrostatic pressure. Now, you want to find the total pressure over here. Hydrostatic, I told you that is equal to H rho g. But you already know that atmospheric pressure is everywhere. Above this liquid column, already there is 1 atmospheric pressure. You add the two and you will find the total pressure as P0 plus H rho g. This becomes the absolute pressure at the bottom of the liquid.